If you're anything like me, then having a teacher tell you this particular concept or this particular equation is true, I can't show you why, you're just going to have to trust me, that sort of thing won't satisfy you. That's why I thought I'd make a separate video on showing why the motion equations intuitively make sense. If you just want to get past physics, you don't really care where they come from and where the equations come from, and you just want to, pass the course, then this isn't the video for you. If you want to develop a deeper understanding of where these equations come from, so you can build up an intuition of them, then this is what this video is going to cover. So let's have a look at our first equation. V equals u plus at. First of all, I want you to have a look at the at. So acceleration is essentially the rate of change of speed. By definition, that's what it is. So acceleration by time is essentially change in speed over the change in time multiplied by the change in time, whereby the acceleration is the change in speed over change in time, which is the rate of change of speed. And then, of course, we're talking about a change in time, elapsed time. So that develops us a change in speed. Acceleration by time is a change in speed. So then it stands to reason that the final velocity of an object in motion is going to be the initial velocity plus the change in speed. Okay, now let's have a look at the second equation. S equals ut plus half at squared. To see why this makes sense, I usually like to factorize the t at the front. So we get s equals t, u plus half at. So as I have just shown, at is the change in speed. So half at will be half the change in speed. Now what I'm about to do, you can only do this because there is a constant acceleration. U plus half at, half the change in speed, is going to give us the average speed. And yeah, once again, it's only true because the acceleration is constant. If it was non-constant, we can't do this. So yeah, then it's essentially displacement is time multiplied by average speed. And that you can see for your speed, distance, time equations. Speed is distance over time, so distance is speed multiplied by time. Except now, of course, we're dealing with vectors. Third equation. U plus v over 2 multiplied by t gives us our displacement. So u plus v over 2, similar to our second equation, we can view that as our average speed, because that's what it is. We have a constant acceleration, so the initial velocity plus the final velocity over 2 will give us the average speed. Multiply that by time, we get our displacement. For the fourth equation, I'm going to have to mathematically show how that is developed. No calculus needed here. It's just, we've got to try to use the other three equations to try to match the left-hand side and the right-hand side. Okay, so we're going to start off with v equals u plus at. Let's start off squaring both sides. V squared equals u plus at squared. So now we've matched the left-hand side. What we're going to do now is we're going to expand the right-hand side. Notice how the 2uat plus a squared t squared has an a in common. We've already matched the v squared on the left-hand side of the equation, and on the right-hand side of the equation, u squared plus something. So if we can get the a out, where we've got what we're trying to prove, our 2as, if we can take that a out, then that'll help us match that form. Whilst we're doing that, however, we can also take a factor of 2 out both the 2uat and a squared t squared terms. So that's going to look like this. So we're almost there. We've matched the v squared equals u squared plus 2a multiplied by something. If the equation, the fourth equation, was to be true, that final term has to be s. So let's have a look at our motion equations. There we go, the second equation, s equals ut plus half at squared. So we can substitute that in to get s in, and that's going to look like this. And then we get our final equation, v squared equals u squared plus 2as. Now, thanks for watching. I hope that by going through why these equations make sense, I've helped you to develop a deeper understanding of them. This stuff isn't necessary to pass the course or to necessarily go well at the course, but having a deeper understanding, at least I find, helps to ensure that I perform better with these sorts of questions. Thanks for watching, and please feel free to subscribe.